Hello everyone, welcome back. The seventh video lecture series on the linear and digital electronic circuits. So in the last class, we discussed about the various applications of op-amps such as inverting, non-inverting, summers, clippers and clampers. And in the clippers and clampers, we discussed about two types. One is positive clipping and negative clipping. Another one is positive clamping and negative clamping. So all those were the applications. And now in this class, we'll see the conversions between analog and digital as well as between digital to analog. So primarily moving into the circuits of analog and digital or into the block diagrams of those, you can see that the various components that are available in the circuits. So now let us see the block diagram. Measurement of various physical variable, which is nothing but the transducer, is the first block. And then moving into the ADC. So ADC is nothing but analog to digital converter. And then there will be a digital logic system, which again converts digital to the analog system, that is DACs. And again, it is being converted into the control of the physical variable, that is the control system. So in between transducer and ADC is the analog electrical image of the physical variable. And between the DAC and the control system, there is an analog electrical output for the control. So now moving with the DAC, that is digital to analog converter. Generally, there are two methods to convert digital to analog, that is weighted summing amplifier and R2R network approach. Apart from these two, there are also many other types, but let us discuss about this in primary detail. So here, let us consider one by one circuit. Moving to the weighted summing amplifier. So this is the circuit diagram of the summing amplifier, and this amplifier shows the conversion from digital to analog. So here all are digital inputs. As you can see, it is zeros and ones, zeros and ones. So now one is connected to the most significant bit, that is to the resistor R, and the following resistors are given as R, 2R, 4R, etc. to the power of 2n. And the last resistor is in the value 2 power n minus 1 R. So this will be the value of the last resistor. So here you can also see that the current flowing through each resistor is given as IN1, IN2, IN3, etc. And the last value of the resistor or the last value of the current flowing through the resistor is I0, and that is connected to the least significant bit, LSB. Also, a reference voltage, V reference, is connected to the input here, and that value of the V reference is given as 1, and the other value which is being grounded is given as 0. So here, the input is given to the inverting side of the amplifier, and the current flowing here altogether is given as IN. And also, the resistance RF is nothing but the feedback resistance, which is connected to the output terminal. So here we can say that the weighted summing amplifiers varies with respect to the resistance and its value which is being connected in the power of 2 power n. So here there is a digitally controlled electronic switch which is also available in the circuit. So here, as it toggles between 1 and 0, the output of the resistance from the V reference to 0 gets converted into and in such a manner that V0 will be equal to minus I into RF. So here, this I into RF represents the analog value, and this side of the input represents the digital value. So here you can see that there is a clear conversion taken between the input and the output and between from digital to analog output. So here we have also represented the advantages and disadvantages of these circuits. So the advantages goes in such a way that it is very simple in construction and it provides a very fast conversion when compared to the other simplifying amplifiers. And now coming to the disadvantage side of it, it requires a large range of the resistor with necessary high precision for low resistors, and it can be very expensive. Hence, the resolution here is limited to a 8-bit size. Now, moving into the R2R network, you can see that there is a resistor connected in parallel where all the resistors have the same value, that is R and 2R. R and 2R. That is why it has come to the name as R2R network. So 2R is here and the R is here. So in this way, the resistance is connected to the the non-inverting terminal of the amplifier, and there is an input resistance R1 and a feedback resistance RF, which is connected with the output resistance V0. And here, this reference voltage is taken as 1 and the output voltage or the ground voltage is taken as 0. Here also, the switch toggles between zeros and ones continuously. So when this happens, there is a conversion from the digital to the analog value. So the output here, V0, is represented as RF by R into V reference, the whole of D0 by 16 plus D1 by 8 plus D2 by 4 plus D3 by 2, which is nothing but the value of these resistance and its converted output. So this also has the similar advantages and the disadvantages. Here the advantage is that only 2 resistor values are used in R2R ladder type, and it does not need as precision resistors as binary weighted DACs, and it is also very cheap and easy to manufacture. And coming to its disadvantages, it has very slower conversion rate for n-bit DAC. Number of different levels is 2 power n, and the number of steps is 2n minus 1, and the resolution or step size of the DAC is analog output by the number of steps, that is equal to VA divided by 2 power n minus 1, and the percentage resolution is step size by full scale voltage into 100%. So this is about its value for the n-bit DAC. And the primary disadvantage is that it has a very slower conversion rate when compared to the weighted summing amplifier. So with this, we are completing the DACs, that is digital to analog conversion. And about the analog to digital conversion, we will discuss in detail in the forthcoming session. Thank you.